Now we're going to return to our empirical phenomenon that was challenging for surprisal theory, which we looked at earlier today. And we're going to use the noisy channel processing toolkit that we've developed in the middle of the lecture to try to continue on with rational analysis and to refine our theory of human language understanding. Recall that with rational analysis, when you have a theory that makes predictions that are at odds with empirical data, you need to go and revisit your underlying assumptions, try to revise those and see if you can get new behavioral predictions that better match the data. So we'll do this. Remember that our empirical phenomenon is the sentence, "The coach smiled at the player tossed the frisbee." This was difficult theoretically for us in the particular way that toss seems to be inducing comprehension difficulty for comprehenders that was not explainable by surprisal theory. The difficulty was greater for tossed than it was for the word thrown or for who was tossed. And this was difficult to understand in the kind of model that we had so far. So before we go on and give an account of a pre-theoretical account of what we sort of want to capture in a mathematical computational model, I want you to take a moment to just introspect about this sentence. Go ahead and pause the video and see what your subjective experiences are with it. And then I'll say a little bit more about this. So go ahead and pause. And now I'll assume you're back. So spontaneously, a lot of people have the experience with this sentence that they feel like something is wrong, that the sentence makes sense, but the sign has to be changed in order for the sentence to mean what it's supposed to be. And I want to explicate this idea a little bit more in the following way. It turns out that this sentence has a lot of what I'll call near neighbors, that is small edits to the sentence that will make the quote unquote incorrect analysis, where tossed is a simple past tense main clause verb, the correct analysis. For example, and you may find that any of these small edits that I'm going to describe, some of them may be ones that you subjectively thought of yourself already. For example, if I change the word at to and in this sentence, the coach smiled and the player tossed the frisbee, now it's the player doing the tossing. Tossed is a simple past main verb, and there's nothing weird about the sentence at all. Likewise, if I change the word at to as, same thing. The coach smiled as the player tossed the frisbee. The player is doing the tossing. Nothing weird about this sentence at all. It doesn't have to be a change of a word, though. It could be an insertion of a word. For example, the coach smiled at the player and tossed the frisbee. Now it's the coach doing the tossing, but still tossed is a simple past main verb. The coach smiled at the player that tossed the frisbee. Now the player is doing the tossing again, but tossed is a simple past tense main verb. Player who tossed the frisbee, same thing. The coach that smiled at the player tossed the frisbee. Now the coach is doing the tossing again, but once again, it's a main verb and so forth. Who would also do the same thing. Any one of these changes will turn tossed from a past participle, passive verb, into a main clause, simple past verb. And so pre-theoretically, what we want to do is entertain the hypothesis that maybe the boggle at tossed is involving the comprehender wondering whether what she thought she saw is what she actually saw. And we're going to try to explicate this a little bit more formally. In the context of rational analysis, what we're going to do is we're using noisy channel theory to revisit our formalization of the model that the environment that the comprehender is adapted to. Whereas before, our model of the quote-unquote linguistic environment for incremental comprehension was that at the sentence level, preceding context was a veridical sequence of word tokens. Now we're going to relax that and say that no, actually preceding context is an uncertain set of inputs. And that's actually going to have a profound impact on how we could potentially analyze this phenomenon. The core intuition that we want to develop is that grammar and input come together to determine possible paths through the partial sentence. This is a lot like garden path processing, where for a particular sequence of words, you might have multiple structural analyses, multiple parses. But now it's going to be for a given input, uncertain input, there are going to be multiple possible analyses that are joint word sequence grammatical structure analyses. So let's develop this a little more. We're going to look at multiple paths. On the upper path, we have what I'll call the vertical path. That's where the word at is treated as the word at. This is going to be the thickness of the arrow here can correspond qualitatively to the probability, the conditional probability of the next part of the input that's being described, given being on that part of the path earlier. This is a thick line because we're treating the path, we're treating the input veridically, and there's nothing weird about the structure. The prior of the grammatical structure is nothing weird, high prior. The low path is lower in probability because we're treating the word at non-vertically. At becomes treated as a perceptual neighbor like as rand. So this is a lower probability path given everything we've got so far. But let's see what the word tossed does. So if you're on the upper path, conditioned on being on the upper path, tossed is a low probability continuation because it requires a reduced relative clause, which is a low probability structure. It's even lower probability because tossed is a ditransitive verb, and the passivization that is required for reduced relativization is actually on the goal argument, the person who's getting something tossed to them, which is a particularly rare kind of structure. On the lower path, in contrast, the word tossed is a perfectly reasonable continuation conditioned on being on that path because it's a simple past main tense verb, or a simple past tense main verb. So we can actually do Bayesian update given the word tossed, and it actually has the effect of basically pushing our belief state from being on the top path to being more likely to be on the bottom path. So the intuition there is that tossed is more likely to happen along the bottom path, so this creates a large shift in belief in the tossed condition. In the thrown condition, on the other hand, just like on the upper path, you'd need this weird reduced relative clause to make the next word thrown. You'd also need this weird reduced relative clause to make the next word thrown on the bottom path because thrown is part of speech unambiguous. It has to be a passive participle. So thrown does not change the belief state about what path you're on. And so it doesn't create this change in beliefs about the past. To formalize this, we take what we've got so far. We take our model with prior and expected evidence. The expected evidence is from this finite state automaton. The prior is going to be a probabilistic grammar. I'm not going to show it to you here, but you can read about it in the references that we have for today's lecture. And we need one more ingredient, which is a way of quantifying this notion of change in belief about the past.